All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we did start our performance measurement module. Let's have a look at what we went over today. First and foremost, let me go ahead and start running this file now because you know it does take a while for it to boot up. And while that's running, let's go over everything we went over today. Now, yesterday we did start this file fresh. There was nothing in it, and as you can see, we have just about 300 lines of code already. So it has been a productive morning. We did go over a lot, and we're going to dive into that right now. So let's go to the top. So first and foremost, let's go here. We will go over the topic of performance measurement. Here we will be measuring how well this model performs. And one common function using regression models like this is the root mean square error. What we should note is that not in every case where we would have the performance measurement function similar to that of loss, as the two are quite different concepts. For making use of the performance measurement, we are able to see if two models have the same performance or have a different performance and which one of them outperforms the other. Now, if we run performance measurement, we'll be able to see which model performs better. Next, we will include this metric in our data preparation file where our CVS is located. And first, we need to import root mean squared from caress.metrics. And go to the top, and you can look at the last import from caress.metrics. You can see we imported the root mean squared error, and that's all that means there. And next, we did that part already. Then we add the metrics equals RMSE to our algorithm. So let me go over to our data preparation file and show you exactly where we added that. Let me go up just a little bit so I can show you. And you can see we added that right here inside our model.compile, and that goes in with the same optimizer equals add-on, loss equals mean absolute error, and then we have the metrics equals root mean squared error. So that's where we added it right there so we can actually run it against our data that we have in our CBS file. And this is the file right here. Now, this is the output once we compile our code with the updated algorithm. As you can see, as opposed to yesterday, we don't only have the loss values, now we have the root mean squared error values. And if we wanted to, we can compare the two sets of numbers and see which one is performing better. So that's what happens when we add the RMSE into our compile. So we got back both sets of numbers here. And it does that for the entire return. So it gives us back both sets of numbers for both. Let me go all the way down so we can finish with today's. Up too far. I noticed that we got back both the loss and the root mean square errors. Now, once the training is done, we'll be able to plot this out by using this in our PLT function. We can actually do the history root mean squared error. So let me go over to our data preparation and show you that one. So as you can see here, so we not only have the plots for the history, our loss, model loss, we now have one for the root mean squared error and model performance. So once we open and observe this plot here and close it, this one should automatically open. Let's have a look at that now. So this is the first one here, our model loss. This is our loss. You can see this is the same plot from yesterday. Now once I close it, the second one should open up automatically the way we have it configured in our code. And there it is here. This is the model performance plot. And this is our RMSE, or our root mean squared errors plot. As you can see, and you can see the numbers are different also. So that's that. Now let's go back to our performance measurements. Okay, and lastly, we'll rerun the history, and this time we will get back both the loss values and the RMS values output. So what that means is, well, first let me go to our data preparation and show you how we did it. So we had to rerun the history equals model.fit, and then we did another history with our fresh data with the history for the root mean squared error. Now what that means is once I close this once I close this model performance plot here, it should open up a new set of numbers like this. Well, yesterday you recall we just got back the loss values, but this time we should get back the loss values and we should get back the RMSE values. So let me go ahead and do that now so you can actually run, and I can show you guys exactly what that looks like. So we close it, and it's going to run through our epics again. Because like I told you yesterday, one is always connected to the other, so we have to run one to get to the other. So it's going to run our epics again, and it should return not only our loss values, but our RMSE values as well. And it's going to be jumbled up all in one big return. So I should have to point it out to you. Let me go ahead and do that now while it's loading. So as you can see here, we do have our loss, and this is our dictionary. This is our list inside our dictionary. But if you scan down here to the middle of the page, I know it's quite hard to see. It took me a while to find it. You'll see the root mean squared error, and this one starts our values for our root mean squared errors. So these are all our loss values, and these are all of our root mean squared error values. They're all jumbled up in the same return, but they're all here. And that's what happens when we do the history again. We get back both sets of numbers. Let me scroll here so you can see it in the actual return here. And as you can see, our losses stop here. And you can see it picks up our root mean squared error. Again, this is the same as this. It's just copied and pasted here so you can see it inside our performance file. And again, that's all we did this morning. We went over different concepts inside our performance measurement. And you can see we dived right in. We didn't waste any time. We're nearly at 300 lines of code already. And yeah, we're going to keep moving right ahead. And I'm going to keep you guys posted every step of the way. But for now, this is the Python Poppy, and you guys stay Gucci.